Welcome back, folks. In today's class, I'll be talking about the continuous normal probability distribution, which is also known as the bell-shaped curve. And first of all, we'll talk about the basics of this curve. So this is how a bell-shaped graph looks like. And if I try and draw a line through the middle section of this one, this line is also called as mean for a normal distribution. So what does this mean is that 50% of the area of this graph is on the left hand side and 50% area is on the right hand side, on this side. And in other terms, in terms of the data, if I have to put it, that let's say if you have 1,000 data points, so you can say that 50% of the data points will be on the left hand side and 50% of the data points will be on the right hand side of the mean line. Now with this, another question will come to your mind, that if 50% of the data points are on the left hand side and 50% on the right hand side, then this should also be called as median line, isn't it? Yes, for the normal distribution, perfectly normally distributed graph, mean will be equal to median. Okay, so that's what normal distribution graphs look like. Another thing which I wanted to tell you, when you're going to look into the probability distribution graph for this one, so in the probability distribution graph, on the first row or first column, I say, you will be given a z-score value, and then some z values will be given on top here, so on this side also. So and then in the middle there will be some probability values given to you in this section here. So what does these probability values represent? First of all, we'll try and understand that. So these probability values, if you see in your graph, they will start from 0.0001. So first thing, the probability values are represented up to the 4 decimal places until or unless you are asked to find out to 3 or 2 or 5 decimal places. So we'll represent the probability to 4 decimal places. And then correspondingly, the z-score, we will always represent it to 2 decimal places. Now let's try and understand what these probabilities are. So I will talk about three things. One is X value, another is probability, and the third thing is z-score. These are the three things in today's class we'll talk about. So first of all, probability. So if you open up your table, probability distribution table, and you will find the probability, first probability is 0.000001, and the last probability on the second page is 0.444 times 9. So again, there will be a bit of an halt. So if I have to show you on the graph, that'll actually be better representation. So let me quickly open up the distribution table for you guys so that you can actually see that one too. I'm gonna give me half a minute and I'll be right back. All right, welcome back, folks. So this is the table which I'm talking about, which is also provided to you in your formula booklet. Down here, there are, in the light blue color, these are the z-scores, and then these are the probability values given to you in this table. And there are two pages which belongs to this one. This is the page number 1, and then if you're gonna flip it, you're gonna see another page on which the probability is gonna look like this. Now, I wanted to understand what these probability numbers are, actually what this signifies. So if I go back into the graph, so these probability values, and if I see, this is the first number, starting from here, and then they move in this direction, and then they continue increasing their values. So 0.2 to 0.3 to 0.4 to 0.0005. Okay, so these values, I'm gonna start them from here, from 0, and they goes up to 0.00999, 4 times 9. So if I show it on this table, you will find right at the end of the second page, the value lies here. Okay. Now, what I'm going to do is I'm going to use the two different words. One is I'm going to talk about probability. Another, I'm going to replace it with the probability word with the area, just to understand it easily. Okay, now we can put it as that, let's say this is the land I bought starting from here and it goes up to this point. So this is my 100% of the area. So from 0% of area goes up to 100% of area. Now, obviously, if I ask you what is the middle point of the area, so you're going to say this is the middle point of the area. I can dissect it into two equal halves from here. So this is the 50% of the land, I can call it. So correspond to the 50% of the land, if I have to turn it in terms of probability, the probability value should be, I just divide it by 100, like percentage of area divided by 100. That will give me the probability. So 0.500. And let's see right at the end of the page 1 what is the value of probability. So right at the end of page 1 it is 0.50. So all these probabilities lies within the first page. Now if I have to study these probabilities, let's say if the probability somewhere given to you is probability 0.3600. Okay, I'm just taking a random number. It means I'm saying 36% of the area. If I multiply this by 100, what's that gonna be? So that's gonna be 36%. 0.036 multiplied by 100 is 36. So it means 36% of the area. From where? So starting from the zero end, it will always be starting from the zero. So this is where the 36% of area will be. As soon as you see the probability of 0.5, which means 50% of the area, but starting from where? 50% of the area starting from the initial point, from the 0 point. Okay, whenever I'm talking about these probabilities, they must refer to a starting point, and there is only one starting point, that is on the left hand side. From here we are referring to all the probabilities. If you see a probability number like this, let's say I'm going to take the number here, 0.666664. So I'm going to redraw a picture here. So it's going to look like this. This was the picture. So 0.66 will be on the other side of 0.5. So that will be somewhere here. So it means 66% of the area. 66 it is actually, let me rewrite it, 0.6664. So 66.64% of the area. From where? From the starting point. This is the area which we are talking about. Okay, now in reality the word area, I will now convert it into the data. So it means if there are 1,000 data points, out of that 66.64% of the data points are covered up to this point in the given question. Okay, that's what it means. Now, that was about the probability. So remember this thing, it always starts from the zero, goes in this direction, and the final probability they've taken it as 0.9999, which approximately equals to 1, but they don't put it as 1 because there are some outliers always. Okay, so that was about the probability. Now we're gonna talk about the second thing, that is the z-score. So you might have studied in chapter number 3 about the standard deviation. So when we talk about the standard deviation, there are two things in the standard deviation. One is S value, which is amount of standard deviation. Standard deviation. It is represented by S for a sample and sigma for a population. Then there was another thing you might have studied, that was K, which was the number of standard deviations. Number of standard deviations. Now, when we talk about the z-score, z-score is nothing but the number of standard deviation. We just replace the k with the z. Okay, so now here I'm gonna keep on, as I said, I'm gonna recall a little bit. So I said in the beginning I'm gonna talk about x, and then I'm gonna talk about probability. Whoops, I don't know why I cannot type in here. I'm gonna talk about probability, and the third thing I said I will talk about z-score. So we still haven't talked about this, but we've talked about probability, which starts from 0 and goes in this direction, and now we are talking about the z-score. So z-score, which means the number of standard deviation also. Z-score right in the middle is 0, okay, where the mean value is. This is the mean value, okay, and you move into the left hand direction for the negative z-score, for in the right hand direction for the positive z-score. So you can recall a little bit when we said that one standard deviation k equal to one standard deviation to the left and to the right. Same way, so you may move one to the left and one to the right, isn't it? One to the left, one to the right. And if k value is 2 standard deviation, it covers the 95% of the values, isn't it? That's what we said. One standard deviation covers 68% of the values. Same process we are applying, but now we are just representing, rather than representing it as k, we are representing it as z. Another thing we are adding is, earlier we were talking about these values as 1, 2, or 3. Now we can talk about z values in the decimal numbers also. So z value can be 1.1. Earlier there was no k value as 1.1. Okay, we said one standard deviation, two standard deviation, or three standard deviation. Z score can be 1.15, 1.16, 1.17, or that for that matter any number in two decimal places. One more time, z value will be up to two decimal places always. So on the left hand side there will be negative values, on the right hand side there will be positive values. So that's how it's gonna look like. And the minimum z value is minus 3.6, and the maximum z value is positive 3.6, positive 3.6. If I look back into the table, which is down here, the minimum value for the z-score is minus 3.6, and the maximum value for the z-score is 3.6. This will cover pretty much every data point in the given question. All right, so hopefully you were able to have an idea about what is z-score and what is probability. Now, you will be given, sometimes you will be given z-score value and you have to find the probability value from that, and sometimes you will be given probability value and you might have to find the z-score correspond to that. So let's look into how can I find the z-score if the probability value is given. So I'm going to take a random point. Let's say this is the probability value I'm going to use. So the probability given to me is 0.9976. Now, correspond to this value, I wanted to find the z-score. So how can I locate the z-score? Z-score, I will look in this direction. First of all, it is 2.8, and then I will look on to the top, this section in this direction. So if I look at here like this, so the z-score value will be 2.82. That's the z-score value will be. This is 2.8 and that this is 0.2. So always up to two decimal places. Okay, correspond to the given probability. Now let's say if you are given the probability of I'm gonna take a number 0.99, I'm gonna say 13. Okay, so I wanted to find the z-score correspond to this. Now if I look into the table, 0.9911, 0.9913, and this is 0.9916. So again I'm going to pick this number and I can find the value correspond to this. Okay, going to go to the left hand side, which is 2.3, And here I'm going to go in the upper direction 2.38. So z-score value will be 2.38, correspond to this probability. Now, one more time, I just want to tell you, what does this mean? 0.9913 on this table. On this table, it means you are covering 99.13% of the area, or 99.13% of the data points, starting from the origin. This is the origin point. Okay, this is the section you are covering. So probability is telling you how much section you are covering. Okay, and correspond to that, the z value, which I'm going to represent on this horizontal line, z value comes out to be 2.38. Now let's say you were given the value as 0.9914. So if I see here, there is no value for 0.9914. There is no 0.9916 after that. So what I'm going to do here in that scenario is, the value which is closest to 0.9914, I'll pick that one. So there are two values, 0.9913. Another next value is 0.9916. So the closer value to this one is this one. So I'm going to still keep the z-score value as 2.38. Having said that, there are a couple of exceptions. If you somehow find the value right in the middle, so something like this, and this one for 0.9950. So for that, you are given these exceptional values. You will take these values. So these are the points for 0.95% of area. In this one, 0.9950. Okay. So, and same way, there are some values up here also. Now, one thing you've understood is that if the probability value is less than 0.5, if the probability value is less than 0.5, then you are in this section, because right in the middle, the probability value is 0.5. And if the probability value is greater than 0.5, you are somewhere in this section. Correspond to this mean line, the z-score is equal to 0. If you are on the left hand side, then z-score value will be negative. And if you are on the right hand side, z-score value will be positive. Okay, now I can see that also less than this value. I'm gonna say, let's say 0.4522. That's the value. So I can look into this graph here. 0.4522 will be where? 45.4522 down here. So this is the negative 0.1, and up here 0.02. So it means the value of z-score value will be negative 0.12. Just let me quickly see. Yeah, 0.12. So that's how you will be able to identify z-score. So we've done two things. One we've talked about is the probability px, what it is. Another thing we talked about what z-score is. Now, in chapter number 7, you are given a formula which is z-score equal to x minus mean divided by sigma. So this formula is nothing but which you've learned in chapter 3. Do you remember you've written the formula x equal to mean minus k times standard deviation, and x for lower limit. This was for lower limit, and this one was for upper limit, that was x equal to mean plus k times standard deviation. Okay, as I said, you're just replacing k with the z and then rearranging this in this form. So x equal to mean minus z times standard deviation, and then what they are doing is this goes on the other side, x minus mean, and equal to z times standard deviation, and then you divide it by the standard deviation. So x minus mean divided by standard deviation for the lower limit, and for the upper limit it is a positive number. Okay, so that's what you are doing. Okay, so it's just nothing new. What I'm trying to tell you is there's nothing new in this formula. All right, now the third thing we're going to talk about is the X value. This is what we have to find. So we've talked about what is z-score, what is probability, and the third thing is the X value. X value will be the actual value which you are trying to find out, or sometime it will be given to you. So for example, for mean, remember I took an example, the average height of a Canadian man, let's say, is 175 centimeter, and it is following normal distribution. So 175 value will be here. So what percentage of the men, their height will be less than 167 centimeters? So that will become, this will become X value. Okay, so basically that's what X value is, and that X value we put in here. So X value, whenever I'm going to solve some questions, I'm going to write here. Probabilities values I'm going to write in the middle section, in this section, and Z values I'm going to keep on writing them on the bottom down here. So that's how that was just a basics of the probability distribution graph, the normal distribution graph. So hopefully you were able to understand this graph. I'll see you with another video. Till then,